without any penalty. So I can't actually make anything be due on Wednesday morning, Tuesday morning, but there's no penalty up to being 24 hours late. In particular, that Tuesday is going to be the end of office hours held by the TAs, and myself and Professor Coe will be doing office hours, most likely by appointment. So obviously we're a bit behind in getting the grades back to you. I am actually hopeful that we will get most, if not all, the grades returned this weekend. There is a chance that we will get basically everything except the lab, returned to you this weekend. We'll see how well that works, but I'm going to be doing a big flushing of the grading system. That sounds kind of odd, doesn't it? I'm going to send out all the stuff in the grading system this weekend, so most, if not all, the grades should be returned then. So obviously there is an exam and a lab quiz next week. It is going to be cumulative and cover pretty much everything until the end of lecture today, which is multidimensional arrays. The focus of the exam is going to be on the stuff covered since the last exam, which is pretty much grading classes and arrays. I'm sure you'll have to write some class at some point on the test. Similar to the previous test, I'm planning on holding a review session probably Monday night. But I won't actually, I don't draft the initial version of the exam, and I won't look the exam until after the review session. So this way I can answer your questions honestly as to, I mean, if you ask something that's very similar to the exam, this way I can answer it without worrying that it's on the exam or not. And of course, the lab quiz is going to be the following day as well. So there's a study I mentioned. It's an online study. If you take part in it, you get $10. I have the forms with me. In particular, and I have to email this out to the class, for those who did take the forms last time, so you do the study. It takes, I don't know, 15 minutes of your time online, and it'll print out a form that's worth $10. You have to turn that into Peggy Reed, who is an Olson 223. I will email that out to the class in case you forget. Let's see, lectures. There's all of 4 more lectures, because obviously we're at the kind of end of the semester. Next week, so today we're going to talk all about multidimensional arrays, and I expect we'll actually pretty much finish up the array chapter. On Monday, we're going to do, I think it'll do exam review, because I think that's probably what people most want to see. Wednesday, of course, is the midterm, so that's going to be so much fun. Friday, I want to spend some time talking about sort of advanced class things. We're going to talk about inheritance. I want to spend some time talking about, things like the clone method, why the vector class we talked about takes in an object, things like that I'm going to talk about. And then the following Monday is sort of course wrap-up. I'll probably spend some time talking about homework 10 on Monday, and then probably next Friday as well after it's sort of sunk in for a bit. And right, so clickers. As promised, I have the clicker list. I just need to figure out the best way to put it online so it's anonymous, because I can't put that, John Doe has this clicker ID, because that's confidential student information. So it's going to be part of the grading system. Once that is all done, I should be able to get to that this weekend. Whoever has had a clicker that is registered in the course, it will say it right there. So, whew. Questions, comments, concerns? So I received another really good comment yesterday on the labs. Yes, I'm going to show it. I had to actually cut some out because it was really long. I started circling all the cursors, but I gave up after like 5 or 10. So the reason I'm bringing this up is if you feel this way, I can completely understand why certain people can feel frustrated. The course obviously is a lot of work towards the end. It was intended to be that way. For various reasons, I need to make it be that way. If you have concerns about the class, This is probably not the best way to phrase this, because really when I look at this, I just ignore it. And then I start anonymously making fun of the person who sent it. If you do have comments, and there were a lot of comments, were actually constructive comments in the lab. Some said it was a bit long. Some said it was a lot of fun. Some said it was just right. Others said it was a bit long. If you do have comments on the lab or homeworks or course, please make them a bit more constructive. Oh, the other thing I wanted to say, so Lab 12. Lab 12 is a do-at-home lab. It's basically a way for us to encourage you to fill out all the course surveys. I actually like all the course surveys. I like reading information. It's a good chance for, after the semester's over, for me to see what you think about the class. There's a chance for you to rate the TAs and say how well they did, et cetera, et cetera. And so that's really what Lab 12 is going to be. Depending on how much time you want to spend in your comments, it could take anywhere from 5 minutes to like a half hour. So Lab 12 is, so here's the thing, is that the engineering school and everybody in the engineering school likes to get student comments, because this way it's part of the evaluation as to how well the class went and how well you liked the class and other comments that you have to say. And there have been various draconian measures imposed to make students do it. And in particular, some of the measures were don't submit their final grades unless they do unless they fill it out. So when you fill it out anonymously on Toolkit, I don't know who I know who filled it out, but I don't know what they filled out. So it tells me that 100 people filled it out, and it tells me alphabetically the list of those 100 people, but of course, it's anonymous, so I don't know what you filled out. So then they said, well, don't submit the grades of those who didn't fill out that survey. I didn't really like that. It was give a grade penalty for those who don't fill out the surveys. That kind of doesn't seem right, because it's a free country. You should be able to, submit or not as you so choose. Then there was the great idea of give a bonus if they fill out the grade penalty. But then the curve gets adjusted, so it really ends up being a penalty anyway. So in this lab, you can go through the lab and not fill out the surveys if you so choose. You still have to do the lab, which basically requires submitting a file. You still have to do the lab because part of your grade counts on it. But if you feel very strongly that you absolutely do not want to tell me what you think about the class, you have every right to, and we won't penalize you. But you still have to actually do the lab. There's two parts to it. There's a toolkit survey, which is the standard thing that you've probably seen before. And then there's, on the grader survey, there's a chance for you to rate TAs and say what you think about the various TAs in the class and such like that. So that's going to be out, I don't know, soon, early next week. It shouldn't take too long. I'll email about it. Questions, comments, concerns? Okay. Someone forgot his pen today. Beep. So, yesterday's lab was a somewhat introduction to multidimensional arrays in that you saw how one accessed a grid. And we accessed the grid, of course, by the getLocation@Method. We gave it a row, we gave it a column, and as usual, I put my row and my column in a different order. And I want to spend some time talking about the actual implementation of two-dimensional arrays. Oh, really? Is that going to work? Oh, bummer. He had a stylus, but it was different technology. Thank you, though. I want to spend some time talking about how you actually use multi-dimensional arrays directly, because this is going to be needed for homework 10. So far we've seen arrays, vectors. It's a linear list. It's a single-dimensional list where one element is right after the other. But obviously there's a lot of things that require 2 dimensions. If I was to lay out a plot of this classroom, it's 2 dimension. There's a number of seats for each row, and then there's a number of actual rows or columns, however you want to phrase it. So obviously there's a lot of examples for 2-dimensional arrays. Matrices, for all those who remember the joys of matrix addition, multiplication, and arithmetic. Graphical animation, the screen on any display is actually a 2-dimensional array. And in each spot you have a color. And if this is 1,000 by 1,000 pixels, which is a decent resolution for a computer these days. That's a 1 million element two-dimensional array, each spot having, red, green, blue values. Economic forecast models, map representation, blah, 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 blah. There's a lot of things that you can do with two-dimensional arrays, including the map for our game. So this is one way to create a two-dimensional array. Int, bracket, 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 m equals new int 3, empty bracket. What that does is that's going to first create, so essentially a two-dimensional array is an array of other arrays. And what this whole process creates is m is a reference to an array of length 3, and each spot in that array is a reference to an array of length 4. So as far as Java is concerned, it's really just a bunch of one-dimensional arrays, but so situated so that the user actually looks at them, the programmer looks at them and can imagine that there's actually 2 dimensions to it. This is saying the first column, if you will, or the first row is a new int array of size 4. This is saying the second row is a new int array of size 4, and the third row is an int array of size 4. And this is saying that I'm going to create a two-dimensional array with 3 columns, and each column of some unknown length. Oh, I'm sorry, 3 rows, and each row is of some unknown length. So this is one way to go about creating a two-dimensional array. This becomes a bit of a problem if you have, 100 by 100 or 1,000 by 1,000 two-dimensional array. It's going to be a kind of long code as you go all the way up to m of 999. Sure, you could put in a loop, but there's another way. Oh, sorry. Just as before, technically m is a reference to the array. We will often be referring to it this way, where just m is going to be drawn next to the array. In reality, it's references. Again, when the array is created, each value is initialized to its default values. So this is another way to go about creating the two-dimensional array, and this is really what most people will go about using. This creates, again, the two-dimensional array, hence the 2 sets of brackets, and it's going to be 3 by 4. So here is the dimension that's 3 long, and here are the 4 dimensions. And this pretty much does the same thing, but does it in one line. Note that you can create 3-dimensional arrays, 4-dimensional arrays, 5-dimensional arrays. You can create as many dimensions as you want. As you create more dimensions, it uses up more memory, but you can certainly create many dimensions in your arrays if you so choose. So this is how we generally will visualize it, because we're going to look at this as a table or some sort of two-dimensional thing. It has 3 columns and 4 rows. So as you probably can tell from the homework, I can't seem to keep my rows and my columns straight, hence why the homework is kind of backwards from the entire rest of the world. It can be 3 rows or 4 columns. It can be 3 columns and 4 rows. We're going to spend some time talking about it. But this is how we will often visualize it, just as a table that way. That's another way of visualizing it. You have an array of 3 elements, and each of those elements contains an array of 4 elements. That's slightly more, this is slightly more accurate than that in terms of how Java represents it. The previous page is exactly accurate. Yes? The question was, do the columns come first? Let's wait till the next slide. Or another. I'm going to address that exactly in another slide. So here, we could do something to our two-dimensional array. Here we have a for loop from c equals 0, c is less than m, that length c increases. So that's going to be the column, 1, 2, 3. And this is going to be the row, going to go up to 4. So this inner loop here is going to be executed 3 times 4 or 12 times, which makes sense because there's 12 spots in our array. So here I am having the column first and the row second. And again, I'll get to your question in a second. And what this does is this asks the user to enter values. It's going to ask a total of 12 times and stick those values into our two-dimensional array. So, of course, the question is, should it be rows by columns or columns by rows? And if I was to create, again, my array this way, it could be 3 rows by 4 columns or 3 columns by 4 rows. It doesn't actually matter how you do it as long as you are consistent. If you always have the column as the first one and the row as the second one, then it's going to be 3 columns by 4 rows. right? Because the first dimension can never go is only 3. The second dimension is 4. You have the columns first, and it's 3 columns by 4 rows. If you always have the rows first, it's 3 rows by 4 columns. So as long as you're consistent as to which to put in the front, rows or columns, it can actually be either one. And that's one of the reasons that I realized as I wrote up the Oregon Trail is I mixed up my order of the rows and columns. But in order to be consistent, I made sure that we kept it that way throughout the entire game. So it doesn't really matter, to answer your question, as long as you're consistent. I did, I think, rows first, columns second. Is that the order I did it in? Yes. Everyone else in the world does it obviously differently than me. Actually, Excel does it the same way. When I was trying to figure out which way I looked at Excel, I'm an interesting company if Microsoft and I do it differently than everyone else. So it can be either as long as you're consistent. So 3 columns by 4 rows, you'll notice that C is going up to 3, R is going up to 4, and you have the columns first. The difference here is that here I have the row first. The order of my for loops, the column is the outer one, here the row is the outer one. And notice what this is doing. Actually, I don't have my stylus. I want to go back one slide and talk about one other thing. M dot length is going to give us 3. Because M, let's even go back another slide. If I was to say M dot length, that's going to give us 3. M dot means follow the reference. That's going to give me 3. That's one of the dimensions. If I say M sub 0 dot length, M sub 0 is this reference. Dot length is going to give me 4. So M dot length is giving me the dimension of the first, or giving me the first dimension, whether it's rows or columns doesn't matter. It's giving me the first dimension. M sub 0 dot length is giving me the second dimension. It could also be M sub 1 dot length, or M sub 10 dot length. Well, in this case it can. It could be 0, 1, or 2. But essentially when I say M dot length, I'm getting 3. When I say M sub 0 dot length, I'm getting 4. So, right. This column is going up to 3, or 0, 1, and 2, right? That's the column. And then this is going up to 4 each time. All right, right. We did that, did that, did that. Okay, question? Yes, you can do 3D arrays as well. And essentially, if you wanted a 3D array, you stick an extra set of brackets there so Java knows that it's a 3D array, and then you stick another value there. So if I put in brackets, another open close bracket there, and then 5, it would be a 3 by 4 by 5 3-dimensional array, and that would be, I don't know, 3 times 4 is 12, 60 spots.
Okay, so if you have like a lot of dimensions, is there a shortcut instead of putting like 5
The question was, if you have a lot of dimensions, is there a shortcut? No, generally, very few people will actually use more than 3, or, I mean, in this class we never use more than 2 dimensions. Very rarely will you use more, a huge number of dimensions. Or if you do, you're often going to write an own customized class that sort of helps you handle some of the dimensions. But if you are doing it strictly by arrays, then there is no shortcut. You have to, if you have a 10-dimensional array, you have to have 10 sets of open close brackets. People almost never use 10-dimensional arrays in practice. But you certainly could. It also takes up a huge amount of memory. 3-dimensional arrays are used in computer graphics, for example.
How can a computer display a 4-dimensional array?
So, there's a really good demo that I will bring. We obviously live in a world of 3 spatial dimensions. And the question, of course, is how do you display a 4th spatial dimension? Well, there's a couple ways to do it. One is time, where every success, the 4th dimension, something changes over time. If you have a 3-dimensional grid and it changes every second, then you can consider that your 4th dimension. Another way is you can color code it. If you have a 3-dimensional grid and everything's in the range, 0 to 255, just assign it a color. And this way, by looking at it, you actually see the 4th dimension encoded as a color. You can combine those and actually start visualizing 5 dimensions if you start having something move with time and color. So a perfect example of this is a TV. A TV is a 2-dimensional a picture. A picture is 2 spatial dimensions, but the color makes it look like there's a 3rd dimension, right? You can perceive, I mean, obviously it's flat, right? But if you have a picture, you can perceive that there's some depth there. You can perceive the 3rd dimension through color. You put it in TV, and it's really 4 dimensions that you're seeing. Time, your 2 spatial dimensions, and your color. So that's how you would go about doing that. And there actually is a lot of research in terms of visualizing higher dimensions. There's this great demo I saw online. I'm going to see if it's still online because it actually talks about how you could visualize, or at least think of 10 dimensions. I'll try to bring it in as a humor break on Monday. Yes.
Could you go back to the slide where you're showing us the references? Could you think of that as from your n sub 0, the whole instead of having 4 across this way, tilt this way and use that? Does it make sense?
You could think of it as you could think of this as 3 rows by 4 columns or 4 columns by 3 rows. Again, as long as you're consistent and always put the row first or always put the column first, you can certainly think of it any way you want. Okay, other questions? Right, got that. So here we go about creating another array. This is an array of strings. Technically, it's an array of references. Each reference can eventually point to a string object. And this is what that array produces. You'll notice that here, the first line, this is creating an array of 4 dimensions that's going to refer to other arrays. That's creating this here. An array of length 4 that will refer to other arrays. Here we have an array of length 4, and each of these lines makes it point to, or each spot points to another array. This is a 2-dimensional array. But you'll notice that the 2nd dimension is not always the same. In particular, the first, we'll say this is row, this is the column, this is the row, whatever you want. This one is only length 2, that's length 3, and that's length 4. This is perfectly allowed in Java, although not actually used all that much. So if we were to take the same code, this is another way to visualize it. And generally how humans visualize things better is this way. The first 2 columns have 2 rows each, then 4, then 3. That's a slightly more accurate way of visualizing it. You have an array of 4. The first array is an array of 2. The second one, an array of 2, et cetera, et cetera. This is called a ragged or a jagged array. So called because the bottom line is not smooth like the 3x4 table we saw a while ago, but the bottom of it has jagged edges, if you will. I want you to know that this exists. We're certainly not going to use it this semester. Generally, if you're putting stuff into tabular form in a computer, it's going to be consistent in terms of the rows and columns. So this isn't used a huge amount, but the computer can certainly support it. Maybe if I was to list each column was a certain student, and you list the classes in the rows for that column, because everyone has taken a different number of classes, that might create a jagged array. So, okay. Have I shown this slide? Okay. So this is a fractal. And a fractal is a pattern that repeats itself. And if you actually look at this, you'll notice that the spiral pattern repeats over and over. You have this overall spiral pattern there, and then that repeats at a smaller level and a smaller level. And I don't know if you can see it from where you're sitting, but that also repeats there as well. And if you zoom in on it, then you end up being able to see this at a really high level of resolution. The pattern repeats on smaller and smaller levels. This is what's called the Mandelbrot. Actually, give me 2 seconds. So the Mandelbrot is probably the most, one of the most well-known fractals. I realize I just have to connect to the wireless network to show this. That's another fractal we're about to see. Come on, there we go. So the Mandelbrot is a fairly well-known fractal, and it kind of has this bulbous body with the head sticking out of it. You notice it repeats here and there, and then this repeats there. There's the bulbous body with the head on it, the bulbous body with the head, and it repeats on a smaller, smaller level. And if you were to zoom in here, you would see kind of the same thing that you see zoomed out. Here's another spiral pattern. Again, this overall spiral pattern that you see repeats on a smaller level, and a smaller level, and even smaller and smaller levels. This sort of galaxy-like spiral repeats there, repeats there, repeats there, et cetera, et cetera. And again, if you were to zoom in on those, it would look kind of the same as this overall thing does. So somebody sent me this great link. And this is zooming in on a fractal. So essentially, this is getting smaller and smaller until essentially we pass by the atomic and subatomic levels. Unfortunately, there's no music with it. I can play Santana smooth. I don't think that would really go with this, though. So the particular way that fractals are designed is something called recursion that we actually haven't seen and we won't see this semester. But no matter what scale you actually zoom in on, there's still stuff to be seen. And even as you're getting on a smaller and smaller, I mean, this must be 10 to the 10th time smaller than what we actually started, because it's zooming in fairly quickly. I mean, this is zooming in, again, not traveling. There's still a lot of stuff to be seen in these patterns. And fractals make popular posters, well, at least when I was in college, a lot of people had fractal posters. Does anybody have them now? No? Some of my college friends still have fractal posters, I might add. To generate this? The question is about generating the computer power. So this is, I mean, it takes some computer power, but essentially it's generating one frame at a time. It's not a tremendous amount more in terms of computation than generating one frame at a time of some other scene. I mean, obviously this entire clip is long. Oh, there we go, and it stopped. Obviously that clip is a couple minutes long, so probably required, I don't know, 1,000 or 2,000 frames. But there are a lot of programs that you can actually get that actually can create fractals, and you just tell it the zoom in level. Huh. I never quite thought of that. So fractals are something that it's a great application of recursion. And for those of you continuing on in computer science, at some point you'll actually see fractals in more detail. How many people have seen fractals before, somewhere or the other? Okay. And you think nobody has a fractal poster? Yes. Okay, someone does. Oh, that's not going to work. Beep. Alrighty. So we talked about explicitly initializing single-dimensional arrays. Turns out, not surprisingly, we can explicitly initialize multi-dimensional arrays. So this, for example, creates a new int array of ints. Notice that in that array, it's going to be ragged or jagged as well. The first two columns, the first three columns have 2 elements each. The last column has 3 elements. So that's actually what it produces. The 2, 2, 2, and then of course that one's going to be 3. So one application of this is matrices. And matrices are one of those things that you, like a lot of linear algebra, it's one of those things that you learn in your various math classes. And then for those of you who end up taking computer graphics, so much, I mean, it is all based on matrices and linear algebra. Turns out the two things are used one and the same. So anytime you are using computer graphics of some sort or the other, there are matrices involved, and the computers are actually doing the matrix arithmetic of one sort or another. So a matrix, how many people have seen matrix arithmetic? I think it's, okay, some but not all. A matrix is essentially kind of like a table in that it has some number of rows, some number of columns. Every spot in that matrix is going to have some number. And here we have some matrix of n columns, m rows, and we can give coordinates to each number. In graphics, 4 by 4 is probably the most common matrix size for reasons we won't get into here. So let's say we want to add two matrices together. If we add two matrices together, first of all, we have to make sure, if you remember from your matrix arithmetic, they have to be the same size. You cannot add matrices together that are of different sizes. So essentially what you do is you go through each spot in the array, like the upper left corner, and you take the upper left corner of one matrix, add that to the upper left corner of the other matrix, and that answer goes into the upper left corner of the answer matrix. And for each corresponding spot, you add the two corresponding spots in the first and second matrix, stick that value into the third matrix, and that's the answer. So for Cij, I is the row, j is the column, or reverse that, whatever you want. It's just equal to, so Cij means a particular element in the answer matrix. It's just equal to the element at the same position in A plus the element in the same position in B. So this is the method that is going to add two matrices together. So public static, right, it's add, it takes in a pair of two-dimensional matrices A and B, and it's going to return a two-dimensional matrix, which I think we call C. So first we want to figure out how many rows are there, A dot length. We are assuming that that's also the same as B dot length. This code doesn't actually check it, but you could, right? If A dot length is not equal to B dot length, and print out ACK, there's a big error. Then we want to determine the number of columns in there, and that's A sub 0 dot length. Again, we assume that's the same as B. So then what we need to do is we now know the dimensions of the matrix. We need to create our answer matrix. We're going to store the answer in there before we return it. Create a double bracket, 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 bracket C equals new double mn. So that's creating an m by n matrix. So now we want to go through row by row. Int I equals 0, I is less than m because that's the number of rows, plus plus I. We go through each column. J is going to be the column. For j equals 0, j is less than n, and again is the number of columns, plus plus j. And we say that that particular spot in our answer matrix, which is C, is equal to the value in A plus the value in B, all in the same spot. And then we just return that matrix we created. So that is an example of how we would go about doing matrix arithmetic. Multiplication is a bit more difficult and not something that I'm going to get into here, but that's sort of the basics of matrix addition. So homework 10, you're going to be creating a map class. That map class, among other things, is going to have a 2D array of locations. And again, that homework will be out very soon. It's due in about a week and a half. So it is not due next Friday, because I'm not that mean to have a homework, an exam, and a lab quiz the same week. So it's going to be a 2D array of location objects. And of course, that's what's printed out in the map printer, and that's where you move to throughout the various map class. We've seen location, blah, blah, blah. Lab 11 is or was, I know when I actually get to this one, is the map printer class, which goes through and actually prints out for each spot some character representing what that is. It's grassland, it's forest, it's a mountain, maybe there's a depot there, et cetera, et cetera. So that's essentially what homework 10 is. I'll probably spend some more time talking about homework 10 on Monday, just because we'll be seeing it in more detail then. How are we doing with 2D arrays? actually, while you're entering all this this stuff in, right after lecture, I have to bolt because I have a meeting. I'm on a university-wide committee to talk about such fun things as like clickers. And it started, yeah, I'm going to tell them about the problems that we're having with this. And it started about 5 minutes ago. So obviously I'm going to be a bit late. So I can't actually chat after lecture. If you do have something that's vitally important, please send me an email. But I have to run to the meeting. I'm sorry? All right.
Wait, what about the surveys? Are they papers out?
Oh, I do have the surveys. While I'm packing up, you can come pick those up. Okay, that's actually fairly good. Most of the class is in here. There's a good amount that's there. So a very small percentage of the class is the 5 and 6. So I'm actually pretty happy with that. All right, so this email, or have you been on this road?
I'm from Bolivia.
Have you been on that road? Okay. Yeah, that looks safe.
Yeah, this is the best part. This is great.
At least they're going in the same direction.
No, you'll see. People like stuck their hand out of the way. He like pushes it.
People like caterpillars. Where did they get their driving license?
New York. I got my driving license in New York. I learned to drive right outside Manhattan, so I wouldn't say that, but
Oh, so this red flag.
I can wear a flag you want right there.
so do you know which highway that mountainous one is? The second one, do you know which highway that is?
I've been on it, but I don't know the name.
Oh, okay.
That's the highway.
So it really does, or road. So it really does exist.
Yeah, it really
Because for, like, you know when you get these things, it could be like all photoshopped images or, so I'm glad to hear that that really is Bolivia. Okay. So I want to spend some time talking about wrapper classes. And you'll notice that the add method of the vector class, it's exciting stuff. The add method of the vector class takes in an object as a parameter, which we said can take any sort of object. Java just allows that to be added. But, right, because that's the prototype for the add method. But you'll notice that, right, because, choked to death, hold on. So we haven't seen it yet, but that can take in any type of object, a location object, a string object, another vector object, anything you want. You can add it onto it. But the problem is that primitive types are not objects. Int, double, float, character, boolean, those are not objects. So the problem is how do we add them to our vector? Because a lot of times we want to have a vector of ints or a vector of doubles. But according to this, you can add any sort of object to it, but a primitive type is not an object. So this is what a wrapper class was created for. So if you want to add an int, and an int type or an int variable to a vector class, you would do this. Create your integer variable. I'm going to create a new integer object. So I'm creating an int variable. I create an int object I of the integer class. The integer class is in java.lang, so it's automatically imported. The whole purpose of the integer class is to be able to take an int value and turn it into an object. It's technically, it's a class that has a single field int value or something equally intelligently named. Its whole purpose is to wrap that single integer value in an object so that I can add that to a vector. You do whatever you want, and then you want to get it back out. So v.get0, you have to cast it back as an integer object. And now J is pointing to the same thing that I pointed to. And then to get the int value back out, you just call the int value method. Integer class has a couple other methods, but essentially you create an integer object and you pass in an int value. So now it's storing. That's pretty much the only instance. That is its only instance variable is that integer value. And then you can get it out to the int value method. And you look at this and you're like, oh my goodness, this is such a pain in the butt. All I want to do is be able to stick an integer onto the vector. And you have to go through all this rigmarole. So it turns out there's a couple ways to get around this. We'll see that in a second. All the primitive types have wrapper classes. And in particular, for the most part, the wrapper classes are the exact same name as the type, but with the first letter capitalized. The double wrapper class is double with a capital D. Boolean's wrapper class is Boolean with a capital B. The only difference is int is called integer and char is called character. So if you were to write double with a capital D, you're talking about the double wrapper class. If you were to do double with a lowercase d, you're talking about the double primitive type. All right. So then consider this code. Here I'm creating an int variable, not an integer object, but an integer variable. And I'm trying to add that variable to the vector. And you would think that this would cause a problem. And it shouldn't work, right? Because I'm sitting here trying to add a non-object, i.e. a primitive typed variable, to something that only takes an object. And prior to Java 5.0 or 1.5 or whatever version we're currently using, Sun decides to give like 3 version numbers to the exact same thing. But prior to that, this would fail. In the current version of Java, it actually works. The reason is, right, this is why it shouldn't work, because we're trying to add a variable which is not an object to a vector. It does work. Because when Java sees this, it knows that if you were to convert the integer variable, int x, into an integer object, then everything would work nicely. And what Java will do is it will automatically, it's called wrap or box. Any integer type, meaning an integer variable and integer value, they'll automatically wrap that in a wrapper class for you without you entering any of the code. This is called auto-boxing, because, or auto-wrapping, perhaps. Auto-boxing because it automatically boxes an integer variable into an integer object. And then the integer object, of course, can be added because vectors like objects. It will also unwrap it, auto-unboxing or un-auto-boxing or something like that, as needed as well. So the previous code will actually be translated into this. And here, what is actually being added is what's in yellow. Java, it will tell you this, but when it compiles it, instead of trying to add the primitive type x, Java automatically adds new integer, that part in yellow, to it, so that it will convert this primitive typed variable into an integer object. And then here, it automatically unconverts it.
So if it doesn't automatically...
The question was, is if it does it automatically, when would you need to write it in? Let me wait 2 slides on that. So this is called auto-boxing and un-auto-boxing or auto-unboxing. If you're using an earlier version of Java, this won't work. This works in 1.5, but not 1.4. So consider this code. And this is something we actually saw a lot on the first homework because people were still kind of iffy about primitive types and whatnot. And you notice here, I say double with a capital D. So I'm not creating a double variable. I'm creating a double object. And I'm assigning to a double object a numerical value. When Java sees this, it will work. And the reason it works is this is what Java translates it to. Here, it's trying to assign a double value to D. So it wraps it in a double object. It wraps this in a double object. It will unwrap E and D into double variables, D.double value and E.double value, add them together, and then wrap that in a new double object. Imagine there was a space there. And then it will print out that value. So this does not get rid of the distinction between variables and objects, but it blurs it. In particular, one of the questions is, the question that was asked, well, why do you ever need to use it? You often won't, but you should know that it exists, because if you start writing code like this with your capital D's for your doubles, it's going to take a year and a half. I mean, this is a lot of extra work that Java's doing for just adding a pair of numbers together. And if you're only creating double objects instead of double variables, it's just Java's going to take a lot more time to actually run your code. So you should know that this exists because this is ultimately the only way you can add an int or a double, meaning a primitive type int or a primitive type double to a vector. You can do it explicitly, or in the current version of Java, it will do it for you. But you should know it exists because this code is going to run really slowly. And if you were to make all of these lowercase, then it would create double variables, DEF, and it wouldn't bother with the boxing or the unboxing. How are we doing with wrapper classes? Yes?
So if you wanted to compare two vector objects, or no, a vector object to like an int in like an empty something, will it work now?
So the question was comparing different objects of different classes. You can certainly compare them with the double equals, but again, that's only comparing the references. There's no way to directly, unless you were to write a method that does it, there's no way to, Java doesn't know how to compare a vector with an int because they're completely different. But you can write something that would compare it. Maybe it'll say true if the int is the same size as the vector, or same as the vector size. But Java doesn't know how to do it, so it would give you some sort of error. Okay, bell curve is pretty much what I was expecting. That will have to wait till next time. Have a great weekend. I'll see you all on Monday.